Hey everyone, it's Justin again. Previously, we learned how to find maximums and minimums on graphs. That knowledge is going to help us with the next important characteristic of graphs, increasing and decreasing intervals. In this video, we're going to be focusing on two main definitions, increasing intervals and decreasing intervals. An increasing interval is the span of input values on which using a higher input will always result in a higher output. That sounds pretty complicated, but all it really means is that on that interval, as the graph moves to the right, it goes up. That definition might sound a little familiar. That just means it has a positive slope. So if the increasing interval is where the function has a positive slope, it's pretty easy to see what a decreasing interval is. It's where using a higher input results in a lower output. Or in other words, as the function goes to the right, it goes down, meaning it has a negative slope. From here on, when we describe intervals, we're going to use interval notation. It's very similar to writing inequalities, except there's always a start and an end. This isn't a point. It's interval notation. Don't get this confused with an ordered pair. It's all about the context, right? We would read this as between 2 and 7. The parentheses here mean that those numbers aren't included in the interval. It's like a strict inequality. We could also change the parentheses to square brackets, like this. This is still between 2 and 7, but the brackets mean that those numbers are included, like an or equal to inequality. We could even mix and match. This one here says between 2 and 7, including 2. And this one means between 2 and 7, including 7. If there isn't a start or end to the interval, we just say it keeps going forever by using infinity for an end value, or negative infinity for a starting value. Anytime an infinity is used in interval notation, we use a parenthesis like in this example, because it's impossible to include an ending when the interval doesn't have an ending. And that is your crash course on interval notation. Interval notation and increasing and decreasing intervals will be much easier to understand with an example. Here's a basic function graph. Let's identify any increasing or decreasing intervals. The increasing interval is where the graph increases as it moves to the right. That would be this orange section here with the positive slope. As the inputs on the section move to the right, the outputs keep getting higher. So how would we describe this interval? Well, since it starts at -2, and as far as we could tell, it never stops, we would just say that the interval is from an input of 2 to infinity, meaning it just keeps going forward forever. Do you think you know what the decreasing interval is? Try tracing over the graph with your finger. The decreasing interval is this orange section. It starts off the graph all the way to the left, and it ends at -2. So we'd identify the interval as being everything between negative infinity and -2. Negative infinity just means forever to the left, just like how infinity means forever to the right. You might have noticed that neither interval actually uses -2 because they use parentheses rather than square brackets. So neither one here includes the place where the input is exactly -2. This is because at this one point where the graph is turning around and changing directions, the slope is neither increasing nor decreasing. It's completely horizontal right there just for a split second. That point doesn't fit into increasing or decreasing, so we exclude it from both intervals by using parentheses instead of brackets. Where are the increasing intervals on this graph? Notice I said intervals, plural. That's because there's actually multiple increasing intervals, these two to be exact. The first interval from -1 to 1 would be written like this. And the second interval would be all inputs starting at 2 and going all the way to infinity. To show that these two intervals go together, we use this symbol to connect them. It's called a union which makes it super easy to remember because it looks like a U. Pause the video now and try writing the decreasing intervals on your own. Here are the decreasing intervals in orange. The first interval starts off the graph to the left and ends at -1, so the interval goes from -infinity to -1. And the second interval stretches from 1 to 2. And of course, since both of these intervals are decreasing intervals, we connect them with the union symbol. So we would say that we have two increasing intervals, -1 to 1, and from 2 to infinity. And we've got two decreasing intervals, from -infinity to 1, and from 1 to 2. Okay, one last example. This time, I want you to pause the video, locate the increasing and decreasing intervals, and write them down before I give the answer. Try it out. Do you think you got it? Let's see. Here are the correct increasing and decreasing intervals. Did you get them right? Remember, intervals almost always focus on the inputs. -infinity to 0 would be this section here that starts off the left side of the graph and continues up until an input value of 0. At that point, it starts decreasing along all the inputs between 0 and 4. And then finally, it turns and starts increasing again from 4 to infinity. Identifying increasing and decreasing intervals is as easy as looking where the graph has a positive or negative slope. Speaking of positive and negative, that's what we're going to be learning about in the next video. Not slopes, but the outputs themselves. See you then.